Hi everybody. So in this video, we're going to look at finding the arc length of a sector when we measure angles in radians. So we'll work through three examples. In example 1, we'll look at finding the perimeter of a sector. In example 2, we'll look at rearranging the arc length formula. And in example 3, we'll look at a problem solving exam style question. So I showed you in the previous video that 2 pi radians is the same as 360 degrees. And we're going to use this fact to simplify the formula for the arc length of a sector. So if we have a sector where the angle is measured in radians and the radius is given as r, then we can find this arc length. This will be the fraction of a circle, and we'll say the angle is theta. So this will be theta over the full circle, which is 2 pi radians, multiplied by the circumference of that full circle, which is 2 pi r. So you can see that the 2 pi's will cancel. So the arc length of a sector is theta times r. This is one of the benefits of using radians. It makes solving problems involving sectors much more simple. So we know the arc length of this sector will be theta r. So to find the perimeter, well, we can add the two radii together. They'll both be 9 centimeters. So this will be 18 plus the arc length, which is theta r. So this will be 18 plus theta, which is pi over 3, multiplied by the radius of 9. We can simplify this fraction. So the perimeter of a sector will be 18 plus 3 pi centimeters. Do you want to try and find the perimeter of this blue shape? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So to work out this perimeter, I'll break up into three parts. We've got the larger arc length, I'll call this L1, and the smaller inside arc length, I'll call this L2. We've also got the 4 units here and here. So the perimeter will be L1 plus L2 plus that 8. So we need to work out L1. This will be theta times the bigger radius. And the bigger radius you can see is 6 units. So theta multiplied by 6. So we'll have 6 times 3 pi over 2. So L1 will be 9 pi units. And L2, this will be the same angle, multiplied by the smaller radius of 2 units. So 2 multiplied by 3 pi over 2. You can see that these 2's will cancel and we'll just get 3 pi. So the perimeter of this blue shape will be the 8 plus the 9 pi over 3 pi, 8 plus 12 pi units. So in example 2, we're going to look at rearranging some formulae. So now we've been given that this sector has a perimeter of 60 centimeters, and we need to find the radius given its angle theta. Do you want to try and work out this radius yourself? You can pause the video, and when you come back, you can check you're working with mine. Okay, so how did you get on with that? If we call the arc length L, then we know the perimeter will be 2 lots of the radius plus the arc length. And the perimeter we're told is 60. This will be 2r plus the arc length, which will be theta times the radius. So then we can tidy this up. We've got the 60. I'll factor out this r, and then we'll have 2 plus 3 pi over 10. So the radius will be 60 divided by 2 plus 3 pi over 10. And when you work this out, we get approximately 20.4 centimeters to 3 significant figures. Okay? Let's try one more question. So in example 3, we've been told that A, E, and D lie on a straight line, and the angle b to e to d is 7 pi over 9. We need to calculate the perimeter of this entire shape. So do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so welcome back. So there's a couple of things to think about here. If we consider this sector to begin with, we know the angle is 7 pi over 9 radians, and the radius is 8. So this will allow us to work out the arc length. I'll call L. So L will be theta r. So this will be 7 pi over 9 multiplied by the radius of 8. And as a decimal, this is approximately 19.548 centimeters. So we have the length E to D. We now have the arc length. We just need to work out the length A to E and A to B. And this is a right angled triangle where we're given the hypotenuse. And because we're told at AED, the straight line, we can work out this angle using angles on a straight line. So what do you think this angle will be? Well, if 180 is pi radians, then this angle will be pi take away the 7 pi over 9. So this will be 2 pi over 9. Now all we need to do is use basic trigonometry to work out each of these lengths. So A to B, this will be the opposite to this angle. So the sine of 2 pi over 9 will be the opposite divided by the hypotenuse. So AB will be 8 times the sine of 2 pi over 9. When we work this out, we get approximately 5.142. I'll mark this on the diagram. So then we can use the cosine to work out A to E. This will be the adjacent length. So the cos of 2 pi over 9 will be A to E divided by the hypotenuse. So A to E will be 8 cos of that angle. And this will give us 6.128. So the total perimeter will add up the 8, the arc length, A to B, and A to E. And to 2 decimal places, this will give us 38.82 centimeters. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and the online lesson from my website, mrmathematics.com. I'll leave a link below.